Hello everyone, I welcome you all to my YouTube channel. So you all know that from past few sessions we have been discussing some of the concepts related to your JEE, right? So we have started matrices and determinants. In that concepts theory related to matrices we have already started. We have seen different concepts, right? Transpose of a matrix, trace of a matrix, everything we have seen. So let's continue with the same discussion, and in the meanwhile, if you are not subscribed to the channel, so do subscribe to the channel and turn on the notification so you will be notified as soon as the video is being uploaded on the YouTube. Okay, so without wasting time, let's start today's concept, that is continuation from the previous sessions, the special matrices, right? Today the concept of today's session is special matrices, right? So what are the special matrices? We have seen classification of matrices. There was one category. The matrices can be classified as special matrices, right? So it can also be classified as special matrices. In that, what all things we are having: symmetric matrix, skew symmetric matrix, unitary matrix, Hermitian and skew Hermitian matrix, orthogonal matrix, idempotent matrix, involuntary and nilpotent matrix. In these two things you will be knowing, right? Symmetric and skew symmetric matrix, there are a lot of scope, right? We have discussed a lot of concepts related to symmetric and skew symmetric matrix. You will also be studied in your 12th NCERT book. But when you come to unitary matrix, Hermitian and skew Hermitian, orthogonal, idempotent, all these things, they are important for your JEE part. They are the concepts from your JEE part. Alright, so we'll see one by one. These two things we'll brush up and we'll see what are the things which are there here. Right, so first one is symmetric matrix. So what is symmetric matrix? As we all know that it should be symmetrical along principal diagonal. It should be symmetrical along principal diagonal. So what is principal diagonal? From left top corner to right bottom corner, right? So if you take transpose, the initial matrix and its transpose should be same, right? Or you can say that Aij should be equal to Aji. I and J are row and column of any matrix. If A is a 3 cross 3 matrix, then A transpose, then its A transpose will be, writing rows as column, you will get this one. You can observe A and A transpose both are one and the same. When it will be possible? When Ij is equal to Ji. When Aij is equal to Aji, this particular thing is possible, right? You can see if I is 1 and J is 2. So I is 1 and J is 2, that forms A12, right? A12 is what? Minus 1. Then if you take A21, that is also minus 1. So if Aij is equal to Aji or A transpose is equal to A, then we call that particular matrix as symmetric matrix. Then what about skew symmetric matrix? In any matrix, right, if A transpose is equal to minus A or Aij is equal to minus Aji, then that particular matrix we call it as skew symmetric matrix. You can see here A is this particular thing, and if you take transpose of this, you will end up with this matrix. If you observe this, A is equal to minus of A transpose, or A transpose is equal to minus A, and if you see Aji is equal to minus Aij, or Aij is equal to minus Aji. A12 is 2, A21 is minus 2, A12 is minus 3, A21 is 3. So Aij is equal to minus Aji or A transpose is equal to minus A, then we call that particular matrix as skew symmetric matrix. So this was the introduction of symmetric and skew symmetric matrix. Regarding everything we have discussed it in the NCERT part. Okay, so you can refer that back if you want more details about symmetric and skew symmetric matrix. Now pause a moment, take down these notes. Then once you take down the notes, we'll continue with the other things in detail. Okay friends, let's see what are the next types. So third one is unitary matrix. When do we call any matrix as unitary matrix? Let's see its definition. A square matrix is still said to be unitary matrix when A transpose dot A is equal to I. So when A transpose dot A is equal to I, that particular matrix A, we call it as unitary matrix. Okay, so that was very simple. Coming to Hermitian and skew Hermitian matrices. So what are Hermitian matrices and what are skew Hermitian matrices? Right. So as the definition says, a square matrix A equals Aij is said to be Hermitian matrix if Aij is equal to conjugate of Aji. If Aij is equal to conjugate of Aji, then we can call it as particular matrix as Hermitian matrix. So how to take conjugate? Write complex conjugate of all the elements which are there here. Alright. So here you can see if Aij is equal to Aji, then that particular matrix we call it as what? Complex we call it as Hermitian matrix. So Aij is there. This is matrix A. If Aij, then what will be Aji? That will be transpose of this matrix. Then conjugate of that transpose will be particularly this matrix, right? So in order to get Aji conjugate, first we should make this is in form of Aij, right? Aji will be what? Transpose of Aij, right? So Aji is transpose of Aij. So in order to get this Aji, you have to take transpose of this. Once you take transpose of this, you will get Aji. Then take conjugate of that transpose matrix. So when you take conjugate of that particular matrix, what are you going to get? So Aij will be equal to Aji conjugate, right? Then that particular thing we call it as what? Hermitian matrices. So you can try this one, you will definitely get. These two matrices are example for Hermitian matrices. Here 3 minus 4i, 5 plus 2i, 3 plus 4i, 5 minus 2 plus I, 5 minus 2i, minus 2 minus I, and 2, right? So if you take transpose of this and take conjugate of that transpose, you will get back the same matrices, right? So then that particular matrix we call it as Hermitian matrices, okay? And what are skew Hermitian matrices? When same thing as symmetric and skew symmetric, Aij is equal to Aji, it is symmetric. Aij is equal to minus Aji, it is skew symmetric. So Aij is equal to conjugate of Aji, it is Hermitian matrix. Aij is equal to minus of conjugate Aji, then that is called as skew Hermitian matrix. So if Aij is equal to Aji conjugate, it is Hermitian matrix. That is A will be equal to A to the power theta, right? And skew Hermitian matrix when Aij is equal to minus Aji or A theta is equal to minus A, right? These are the example for skew Hermitian matrices. So I hope the idea of Hermitian and skew Hermitian matrices are very much clear here. So now pause a moment and make a note of this. So friends, I hope that previous concept is clear. Let's move on to the next type. So already we have discussed 4 types, that is symmetric, skew symmetric, unitary, and Hermitian and skew Hermitian matrices. So I hope those things are clear. Let's proceed to next one. What is next one? 5th one is orthogonal matrix. So when we call any matrix as orthogonal, so to call an matrix as orthogonal, it should be a square matrix, as it is said. Any square matrix is said to be an orthogonal matrix if A into A transpose is equal to A transpose into A is equal to In. What is In? Identity matrix of order n. And this A also is an identity matrix of order n. Sorry, A is also a square matrix of order n. If A into A dash, that is equal to A dash into A, and that is equal to I of order n, then we call the matrix A as orthogonal matrix. So that is very much clear. So next, idempotent matrix. What is the definition has to say about this is, a square matrix is said to be idempotent matrix if A square is equal to A. If A square is equal to A, then that particular matrix is termed as what? Idempotent matrix. Anywhere where you get A square as equal to A, then that particular matrix A is said to be idempotent matrix. Next, involuntary matrix. So what is the difference between idempotent matrix and involuntary matrix? It is also square matrix, it is also square matrix. Here A square is equal to A, then it is idempotent matrix. If A square is equal to I, if A square equals I, then that particular thing is called as what? Involuntary matrix. So what is orthogonal matrix? Where A into A dash is equal to A dash into A is equal to In. N is the order of identity matrix. Then what about idempotent matrix? A square is equal to I, right? So A square is equal to A, that is idempotent matrix. And what about involuntary matrix? The matrix where A square is equal to I, right? That particular matrix we call it as involuntary matrix. Now comes nilpotent matrix. So what is nilpotent matrix? What is the definition of that? A square matrix is said to be nilpotent if there exists a common integer m. If there exists a positive integer m, a matrix is said to be nilpotent if there exists any positive integer m such that a to the power m becomes equal to 0. So if A is any matrix and m is any integer, right? So such that there exists m an integer such that a to the power m, that matrix A whole power m will be equal to what? 0. that particular condition is existing, then we call the matrix A as nilpotent matrix. The matrix A as what? Nilpotent matrix. And what is the condition? That m should be a positive integer, and m not only positive integer, m should be least positive integer, right? So for example, for many integers it may be possible that a to the power m becomes 0. For m is equal to 1, 2, 3, 4, so on. For any value of m, there may be some matrix A, right, such that for more than one value of m, a to the power m may become equal to 0. Then all those matrices cannot be called as nilpotent matrices, right? Only for the value where m is least integer. M is least integer. For example, for 2, 4 and 6, if a to the power m, a to the power 2, a to the power 4, a to the power 6, all these are becoming 0, then all are not called as idempotent matrix. Only least integer. What is least integer? In that 2, 4, 6, out of 2, 4, 6, what is the least integer? 2, right? So that 2 itself is considered as what? Idem. That only should be taken as m, and that a to the power m is called as what? Nilpotent matrix, where m is called as index of nilpotent matrix. A is nilpotent matrix and m becomes index of nilpotent matrix. So friends, this was the special classification, right, of matrices. So you may have seen skew matrix, symmetric, all those things, but these things you might have not heard about. So these are very important points from your JEE concept. So go through this video, make a note of this video, go through these things very clearly. Wherever you get, you can comment me in the comment box. So also, if you feel like this is helpful for you people, you can share this video in your group so that you others may also be benefited, right? So do subscribe the channel so that you will be benefited with the uploads whatever I am going to do it. Okay, so let's take a break here and let's continue the next topics. And next class will be very important. Next session I am going to discuss about adjoint of a matrix, right? If you are able to calculate adjoint of a matrix very easily, there is a very big headache. You have to find minus cofactors, then you have to go for adjoint in normal process. So if you are doing all those things, then it is going to be headache for people. So I will tell you the trick by which you can easily calculate the adjoint. Then once you calculate the adjoint, it will be useful for you to calculate A inverse also. So let's see those things in the next topic. So don't forget to log in into the channel for the next topic, right? As soon as you get the notification, you can observe the video, right? It will be helpful for you people, and if you share it in your group, it will be helpful for your friends also who are not connected with the group. Okay, so at right moment we'll take a leave. Take care. Goodbye.